In this video, I want to go through the test application very briefly. So in the test application, which is the main vanilla test.cpp, you're going to see that under the main, it's like a microcontroller. It's an embedded system. It's actually a microcontroller that is being programmed. So we have an infinite while loop that is doing the following. It's actually testing the timer, then we test the LEDs, then we test the switch or the switches, and then we test the UART. And then I have this debug message, which is really interesting here. I'm going to show you what this means. So let's figure out what these do. It's actually function. It's just calling functions. But before we figure out what these functions are, I need you to know that all of these need drivers. So before you use the timers or the LEDs or the switches, you need to actually specify the timers, or the drivers for them. So the drivers for the general purpose output, the general purpose inputs are here, and as you might see them here or might pay attention to it, they're defined as global variables. And the reason why is because we need all the functions in here to get access to them. This is in a general computing system might be considered really bad programming habit to actually use global variables, but in an embedded systems, because these classes can get really large pretty quickly, and I only have 128 kilobyte available to me, so I don't need to or you shouldn't be defining different classes or instances of this class everywhere. You might be playing with pointers and whatnot, but it's the easiest thing to do is just do it with the global variables in here. Okay, so now we have the LEDs and the switches are defined. Of course, you might ask where's the timer and the UART, and as you probably remember, we have included this particular file, which actually includes a lot of other helper files, and it will usually instantiate this particular instantiate the UART and the timer because they're going to be constant across all our code. Okay, so now we can jump into the others. Of course, the GPI core and these cores are actually included in a different header file, so you're going to have to include that. Remember, you need to include a header file for every driver you do, and then after you include it, the first thing you do is actually create instances of these drivers. Now, next, what you do see in this code is actually these functions. These functions, each one of them is separate. So let's take a look at the timer core, or the timer check. So the timer check, what we're doing is we're passing the LED. Basically, we're passing the driver to it, or which is an object of the class. Okay, and you can see in here what I have is I have basically a for loop that is repeated 5 times. It actually writes something to the LED, and remember that LED, it's a GPO core, so it's included in here. If I need to know what the GPO core does, I can just go to its header file and figure out it actually can write something or write a single bit. What this is doing, it's just writing for like the whole thing. I'm using write, that means I'm writing all 16 bits together, and I'm just writing FFF, and I'm waiting for 500 milliseconds, and then I'm writing zeros. Basically, I'm turning all LEDs on, waiting for half a second, turning all LEDs off, waiting for half a second, and then this debug here is technically at this point doing nothing, but generally speaking, we can actually see some debug messages if we choose to, and I'll show you how in a few seconds. And it just repeats 5 times, and this is probably what you do see here. You don't see it on the FPGA because it's programmed without that. What we need to do is we need to compile it just to get to see that, and then we program the FPGA once it's done, and we do this in here, and now we program it, and you're going to see that the very first pattern that it gets repeated is actually the all LEDs on, all LEDs off for like half a second, on and off for like about five times and whatnot. Okay, so while this is being done, we can actually check. There you go. You see it, this is the pattern that I'm talking about, and then it moves after it finishes. You can see in the main, it's actually going to the LED checks, and the LED check, we can read that function, and you can see in that function, LED check, it's doing pretty much almost the same thing. It's going from that to N, and N I'm passing, I believe I'm passing 16 because I want all 16 ones of them. Like if you want less, you can actually pass 8, and it will just let only the first 8 LEDs. And what you're doing is basically you're writing S, which is basically in here, which is basically reading the switch. Well, this one here, I'm writing the wrong one. I'm turning 1, keeping it for 200 milliseconds, turning it off, and then go into the next one and the next one, and you can actually see it. It utilizes again the general purpose output and the sleep MS basically, which is the timer. This is based on the timer. You can see that the switches are pretty much the same exact thing again. Like the next one, I believe it's actually checking the switch. Read it on your own. It's really not that difficult. It's just reading the switches. Where is it in here? The check switches in here. It will actually read the values of the switches, and based on these values, will actually write them. And you can see in here At some point you'll see that pattern. It just light the LEDs right on top of the switches that are asserted. Read that. So more interestingly is actually the UART check. So in the UART check, you can see that it's actually doing a few things. Basically, a loop is 0, whatnot. Like this static here, it keeps that variable. After you finish calling that function, that variable will not be destroyed. You can actually stay, and you will keep that value. And what I'm doing is I'm displaying some string, the number of that loop, and a few basically new lines and carriage returns, and I'm actually adding something to the loop and so forth. So where is that being displayed? Well, as it turns out, it's being displayed, it's actually sent over the USB through UART. Okay, and we're going to talk about UART later, but what we can see is, you can see it on the console. So let me show you how we connect it. Alright, so this particular UART is going to be displayed on a console, and there's a couple of ways to do it. The easiest of which is actually to download the software similar to this PuTTY in here, or maybe PuTTY itself. It's free software. You can actually download it, and you can say, hey, here's PuTTY, for example. And what you do have a serial communication protocol. This is what a UART is, a serial communication protocol. And on my computer, it happened to be connected to COM4. You're going to have to check which COM that you have connected in your computer. And once you do, all you have to do is just basically click open, and you can see that it started to display certain things on the screen. So this is UART test number 13, and after it finishes, like every single time it gets to it, it will actually display something. So let's go back to the functions just to see it, and you can see that that function in here, which is a UART check, it keeps a variable of type static. It actually initially gives it 0, and then it gives me UART test number, and it gives me that number, and then it gives me a new line, and that carriage return, it increases it, and the next time I'm going to see something else. So as you can see, that basically test is telling me it was 13, 14, 15. Of course, I can reset it. If I actually go and reset the processor here, you can actually see that that loop will be reset to 0, or so I certainly hope so. So this is one way to display that particular output or particular console. There's actually other ways to do it. In Vitus, you're gonna actually see it in here. You can see I believe if you do new or open a console in here, and you say I have a command shell console, and then you're gonna tell it like, hey, I need something as a serial port, and you can basically call it like connected to COM4. You can call it whatever you want to call it, UART test, for example, or something like that. And you're gonna have to select the baud rate to be 9600, because this is by default how it is set up on our board. And then you're going to create finish. I think I have to close this one here first before I actually be able to actually see it. And you can see that now it's connected, and I should be able to see these tests shortly. Okay, so this is the UART. You can actually send something to the display, and yes, I was able to see it. You can see it in the display, but more importantly, actually, you can see that throughout my code, you're going to see that I have a debug, and then I've passed a string and then a couple of numbers. But they're not doing anything, and the reason why they're not doing anything, because they're actually turned off. So what I need to do is I need to define this particular compiler directive, which is called _debug in capital letter. If you actually do declare it, as it turns out, this init true init here, the initialization, actually have some code. Let me just show you that. It has some code that deals with this particular case specifically for the debug. So this one here tells me I'm going to define something that is debug off and another one that is debug on, and based whether you actually have created that declare that particular compiler directive or not, I will be displaying that function or not displaying it. So now, because I have went in here and I actually uncommented it, whenever you see a debug, you're going to see a message happening at the console. So of course I'm going to have to save it and basically build it, go in here, build it on the FPGA, just do that. And I'm gonna go to the console, which is probably somewhere in here. Okay. Okay, we're gonna go to the console, and it's probably this particular console in here, and you can see now all the debugging messages are happening. So you can see this is the timer check. So if you go to the timer check, you can see that there's a timer here that tells me I'm within the timer check which loop, and it tells me basically the number of the loop and what is the time now in second. And you can see in here, because I'm waiting for exactly 500 millisecond, it's actually doing that 500 millisecond, 500 millisecond, and so forth. I believe it's doing it 500 and 500. That's why we see 1,000 and 1,000. So it's actually every second. And as you can see, the UART test is happening in here. And whenever you see there's another timer check in here, the debug, There's a bunch of these debugs. You can actually insert them whatever you want, and there's actually a debug for the main, and this is the one that we see in here. Okay, so that's that. This is why we have the UART and the timer, and the timer and the UART will be really useful in debugging code if you're writing code in here in C. Again, we're not dealing with Verilog at this point because now you're wearing the hat of an application developer. You're not even writing drivers here. Someone else wrote these drivers for you.